Hello, I am Alexis Pister. Today I will present ComBiNet, an interface for visual queries and comparisons of multivariate dynamic bipartite social networks. This is a work done during my thesis with Prieur and Jean-Daniel Fekete at INRIA and Gustave Eiffel University. This is what looks like the final interface, but first, let me present you a bit of context. This is a work done in collaboration with social historians who leverage historical documents to make observations on social relationships and interactions of people at a given place and time. Here are examples of the historical documents studied by the 4 historians we collaborated with. This includes marriage acts, migration forms, birth certificates, and death certificates. To study social interactions and relationships, historians can rely on social network analysis and visualization. They model the relationships extracted from the documents into a network that they can analyze in depth. Here is a famous example by Paget and Ansel, where they explained the rise of the Medici family in Florence during the 15th century by their central position in the economical, political, and kinship networks of the powerful families of the city. However, creating a network from the documents is a long and tedious process and requires several processing steps. They first have to digitize the document's content, annotate and encode the relevant information, and model it in a network structure. Several network models exist and are used, but each have advantages and drawbacks. In this work, we modeled the historical documents as multivariate, dynamic, bipartite social networks. So what are they and why are they efficient for modeling historical documents? Let's start from an example of 2 historical documents of construction in Piedmont in the 18th century. Each document have dates, a type of construction, and people associated in the construction under different roles: associates, guarantors, and approbators. One of the most straightforward ways to model those documents is to represent each individual as a node with an identifier, and connect them through links modeling the types of their relationships. We obtain what is called a directed multiplex network. However, this type of modeling has several limitations, the first one being the traceability of the links. For a given link, how to know what document it refers to? Since the documents do not appear in the network, we often cannot. Moreover, for complex relationships such as the ones of the given example, several modeling can coexist. Here, the approbator links can link together only the associates, but also the guarantors depending on how we see the relationships. To solve those problems, another solution is to model this type of data as bipartite networks. In this model, both the persons and the documents are modeled as nodes. A link refers to the mention of an individual in a given document and models its role. This network model solves the issues listed beforehand, as the relationships are traceable from the network to the raw documents, and there is a unique way of modeling the sources into the network. Moreover, this model allows historians to study the information related to the documents and events directly through the network, by adding extra information on the document's nodes, such as the time and location of the documents. Extra information can also be added to the people nodes, such as their family and profession. The final model is therefore traceable to the sources, represents the documents faithfully directly in the network, and is simple enough to manipulate. We decided on this data model with our collaborators after several discussions. At the same time, we collected questions they had on their data and their requirements, and followed an iterative design and development process to create a visual analytics system for historical network visualization and analysis. We first collected all the questions they had on their data. Here are examples questions from 2 of our collaborators. The historian working on construction in Piedmont was interested in the differences in the constructions in Torino and in Torino's surroundings, and if people were mutually guarantors to each other, in different documents. The historian working on French genealogy wanted to locate the main migrations in her data, and knowing when did they occur. Moreover, she was interested in knowing the differences in volume and location between migrations in the 18th and 19th centuries. Another issue raised by our collaborators was the handling of homonyms. Indeed, it is very frequent to find mentions of people with the exact same name, such as fathers and sons. Several geographic places can also share the same name, and a disambiguation step is always required, often done by the historians during the encoding process by giving identifiers to the entities. From the issues raised by our collaborators in their current workflow and their analysis questions, we identified three main requirements for the visual interface. First, the visual expression of dynamic multivariate bipartite networks. Then, being able to isolate and study groups and patterns of interest in the network. Finally, being able to compare subsets of the network according network and attribute measures. Here is the final interface. The data is explorable with an interactive node link visualization and a map showing the geolocated entities. At the left, the visual query panel lets users create network filters visually with a small node link diagram and widgets. At the bottom, the network measures panel shows measures about the network and the filters for historians to analyze and report. The attribute selection panel allows historians to select attributes to align them on the visualizations and explore their distributions. Here, the year attribute is selected, highlighting the nodes given their associated values. Finally, at the bottom left, a provenance tree shows the different actions that led to the final query, such as node creation or deletion. It is also possible to go back in the tree to explore other branches, enabling easier exploration. The visual query system allows users to easily create topological and attribute filters with the help of an interactive node link diagram and widgets. Here is an example of the visual query system used to retrieve people who are mutually guarantors to each other in two different documents. That was a question of our collaborator. The visual query is translated into the Cypher query language that is shown and directly modifiable in the interface. The visual and textual representation of the query are therefore synchronized. Here is the associated provenance tree that corresponds to the constructed query. The user can go back to any previous step of the query construction to explore a different path. Now, I will present how the system has been used to answer the second question of the historian, which is to know the differences between the constructions in Torino and Torino's surroundings. The user first creates a query to retrieve all the documents in Torino, with the help of checkbox widgets. We see the visualization update in real time. Then, it does a second query to retrieve the documents in Torino's surroundings. Here is the provenance tree that led to the construction of the two queries. It can mark the query nodes as A and B for Torino surroundings and Torino. You can then launch the comparison mode where the buttons appear at the top. You can then rapidly switch between query A, B, the union, the intersection, and the difference. You can then explore the different distributions of the two queries and the intersections with the help of the attribute buttons. Attribute distributions let users answer some of our questions. At the left is shown the distribution of the types of constructions in Torino and in Torino's surroundings. We can see that religious sites were mainly constructed in the surroundings of the city, corresponding to query B, which is interesting to our collaborator. At the right is shown the betweenness centrality, a measure of interest for a collaborator. The histogram shows that the intersection of the queries A and B that corresponds to people working on constructions both in Torino and in Torino's surroundings have a higher betweenness centrality overall. This demonstrates that this corresponds to a specific population of individuals that collaborate in the two locations and act as bridges in the network. Now, I will show how ComBiNet have been used to answer questions on the French genealogy datasets. The first question was to know if there was differences in volume and location between migrations in the 18th and 19th centuries. Here is the interface in comparison mode. The query A in blue corresponds to the people living in the 18th century with their birth and death certificates, while the query B in red are people from the 19th century. The comparison selection allows users to rapidly select one of the two queries, the difference, the union, or the intersection. Here are the migrations between French departments in the 19th and 18th centuries, represented as Sankey diagrams. We can clearly see there is no migration in the 18th century and some people moving places between their birth and death in the 19th century, mainly from Haute-Vienne to other departments. This was revealing to our collaborator. The second question of our collaborator was to retrieve the main migrations of successive generations. For this, the historian created a path of successive generations on the node link visual query, interposing birth and union of father and mother links. The union of different roles is expressed as dashed lines on the visual query system. The historian could then explore the different migrations on the map and check the specific department values in the Sankey diagram visualization. She saw that the majority of the population was living in Haute-Vienne and was staying there. She also detected in the Sankey diagram a group of people living in Creuse and moving in Haute-Vienne across two generations. That was interesting to her. Finally, here is ComBiNet used for the exploration and data formatting of a database of marriage acts in Buenos Aires in the 18th century. Our collaborator thought there were identification errors in the data due to homonyms. He thought some individuals with the same name and ID were in fact different people. To find those errors, our collaborator can query people who are mentioned in two marriages being more than 70 years apart. The filter is expressed here as a widget. The results are therefore errors in the annotations of homonyms in the data. You can then look and export the document table to correct the annotations from the document IDs. After demonstrating that ComBiNet can be used for answering historical questions, we did a formative usability study with two historians and one visualization expert. We ran 3 sessions with each participant and asked them their feedback while they were operating the system. It led to the addition of the under button, the document and person tables, the coordinated selection, and the improvement of the comparison mode, by associating colors to queries and by having to mark the nodes in the provenance tree before launching the comparison. The current system still has some limitations. If queries are writable in textual format with Cypher, most historians do not know this language and were solely using the visual query system. Then, time is explorable through filters but is not shown explicitly in the visualization yet. Finally, we try to make the data importation as easy as possible, but is still a barrier for historians and often necessitates ad hoc processes. In summary, this work aimed to provide a visual interface for network analysis and visualization for historians, modeling their data as multivariate dynamic bipartite social networks. We did a requirement analysis from discussions and set 3 main requirements for the interface: exploration, querying, and comparison, according to the topology of the network and attributes. This led to the creation of the ComBiNet system, letting historians explore in depth their data and answer their questions. We validated the system with case study and a usability study. Thanks for watching.